Hi, everybody. Thanks for joining. Great to be here today. Very exciting topic to talk about. So I look forward to taking you through this webinar today. Quick note on the agenda. So we'll be going through some kind of state of affairs of where we are today with agentic AI in the enterprise. We'll talk about Gravitee AI agent management and how we help companies, industrialize AI agents. And then I'll take you through a very flashy looking little demo which involves multiple AI agents, MCP servers, LLMs, and all that kind of stuff. So very, very exciting little demo to show you there. So without further ado, just wanted to kick it off with a bit of a quote here by a British mathematician in the 1960s. The first ultra-intelligent machine is the last invention that man need ever make. I think it's a very relevant quote looking forward, how many years, 60 years later, if you think about it, the research behind neural nets and LLMs dates back to the 50s. ChatGPT was first released to the public in November 2022. 2024, you could argue, is the year when AI agents really started to see adoption. And when you think about it, LLMs on their own were, very cool, but it was difficult to see how they could be used to do something meaningful in an enterprise. And I think AI agents didn't just take off because they became autonomous. They also took off because of integration, because they're able to connect to our applications and systems to get the latest data to take action in the real world. And change is now happening, faster than we'll to react to it. There's a new AI inflection point every few months. We've been tracking the performance of AI models in areas like coding for a while, and we certainly experiment a lot with this internally at Gravitee. And it's actually interesting to see that now some of these researchers are measuring AI progress by the time horizon of tasks. So how long it takes for a human expert to complete a task that AI can finish in a reliable way as well. So the complexity of tasks that an AI can handle is growing very, very fast. And the length of tasks that AI can execute is doubling every 7 months over the last 6 years. So that's where you get that curve. So basically, if this trend continues, research predicts that in the next 2 to 4 years, we'll see AI agents capable of autonomously completing tasks that take humans entire weeks or months to finish. And I think this really reflects, the evolution in the foundational models really reflects the potential of what we can do with AI in the enterprise. And 2026 will be as big a year as ever. Now, related, so we're seeing this transition from Gen AI to agentic AI. Companies have had this initial experience with Gen AI, using it to passively create text or code in a sort of with prompts and that sort of thing. We're seeing a move from that towards agentic AI, which proactively pursues goals to execute tasks. Enterprises are basically transitioning from using AI to kind of describe work to actually doing real work. And orchestration is also becoming key. So agentic AI doesn't live in a chat box anymore. It lives in a workflow. It needs access to tools, APIs, databases, applications, so it can click on buttons and move data just like a human would. And so this requires a real shift in the way we look at this technology. And success now depends not only on the model, but also how well you integrate it into your backend systems. And the end-to-end value we're getting from AI is also drastically changing. We're going from improving individual productivity, so writing emails, generating images, to solving entire business problems end-to-end. So this transition really represents a move from novelty to utility, and I think that really reflects the state that we're in right now, and the transition we're all going through, and that we're basically all aiming for here together in this webinar, I'm sure. Now, we've talked about the why, the what agentic AI. In terms of how we actually go about this, there are actually a kind of a new type of infrastructure that's required to support agentic AI. And I've based it around 4 pillars here. It's kind of one angle, one lens through which you can look at it. The first is the brain. So you need managed access to LLMs. So, we need a gateway to the models so that we don't want to just rely on a single provider. We need a layer that gives us a bit of independence between our agents and our applications and the model and the provider. And we want to control costs and filter for PII and swap out models as new ones become available without having to rewrite or impact all of the upstream applications that are using those models. Then we have the hand. So basically the agent is only as good as the tools it can hold. So this is where MCP comes in. People talk about it like the USB port for AI. Instead of building custom integrations for every single agent, we want a standardized way to expose data and applications to agents. And so this lets developers build agents that can instantly plug into any context and any application and actually do useful things. Then there's the teamwork aspect. So this is all related to multi-agent orchestration. One agent can't do everything. You need specialized agents. If you try and build one huge agent that does everything, you're going to burn a lot of tokens. You're going to blow up your context window. It just won't work. So we now need these kind of orchestration agents. We need inter-agent collaboration. And this pattern is only going to grow as we deploy agents more and more in the enterprise. And the last pillar is the badge, which is agent identity and access management. And possibly, we believe, to be honest, one of the most important and things that we'll see getting the most attention this year in 2026. If an AI agent is going to read emails or execute trades, it needs an identity. We can't just let an agent inherit the permissions of a human that prompted them. That's a security nightmare. We need kind of non-human identities, and we need to define exactly what an agent is allowed to see and do, enforcing the principle of least privilege, just like you would for a new employee in a company. And these are things that really have yet to really manifest and be implemented. And this is what will really unlock that value in the enterprise. And we're used to securing software that does exactly what we tell it to do. But obviously, agentic AI is different. It does what it thinks it should do. And that shift creates a very different vertical risk that starts at the model and goes all the way up to our organizational identity. So the lowest level is the model itself. This is where you'll hear things like prompt injection. I invite you to go check out the OWASP top 10 LLM security risks that were raised recently. Very interesting document. And that's the foundational level. As companies, obviously, we're mostly going to be using off-the-shelf models from different providers, and we kind of rely on them to build in a certain amount of guardrails at the LLM level. And that's obviously something we have to build on top of. The second level is the application level. So this is, as you move up, basically an AI is using an LLM, but it's connecting to MCP servers and tools. And the risk there becomes excessive agency. An agent can get stuck in a loop or hallucinate on a goal. It can start making thousands of calls, incurring a lot of cost and all kinds of things. And the third level is the enterprise. So this is kind of the biggest risk here is more around identity. In the past, every action in our logs could be traced to a human with an identity. Now we have these non-human identities logging into Salesforce or sending emails or pushing code. And if we don't treat these like employees, then there are real risks of these kind of shadow AI workforces that are doing things and we don't really know what they're doing, who's doing them, under which consent and responsibility. And so from our point of view, we're not debating if these problems exist. We are seeing them emerge today. We've done a very interesting survey of that we call the State of Agent Security, and it's State of AI Agent Security, sorry. And it's coming out in a couple weeks, so keep your eyes out for some very interesting data that we've managed to curate for you about where things are today. So we believe that the right time to establish your AI governance strategy is now. Obviously, we've been in the API management space for a decade now, and we've seen many companies come attack API management a little bit late and have to really advocate and evangelize for people to bring their APIs into their API management platform to be governed, to be controlled. As AI is now being deployed across the company, we have an opportunity to establish a stronger level of governance from the get-go, rather than doing it too much after a fact. And we also believe, of course, that technologies like API management platforms are very well positioned to address these new agentic use cases, and that's what you'll see Gravitee doing this year in many regards. So Gravitee AI Agent Management is all about helping you govern AI agents. We can basically manage AI agents as first-class citizens, and they're not black boxes. We're able to actually track what they can track and also control what they can discover and what they can do. We can also help you control AI cost at scale. So that means that you can deploy AI, you can deploy access to LLMs, you can deploy agents across your organization without losing control of the potential costs and other risks that come with that. And we also strongly believe in this single control plane for AI. So first and foremost, we provide controls across every agentic interaction, whether it's LLMs, MCP, A2A, agentic identity, etc. but also it's a single platform that can manage your REST APIs, your event streams as well. And that obviously plays nicely together because some of the things that you'll be wanting your agents to consume are your REST APIs and your event streams, possibly transformed into more agent-friendly protocols like MCP and whatnot. So just highlight a few of the core capabilities that we've been working on recently from a product point of view. Every agent, as I see it today, basically needs three things. It needs access to LLMs, so the brain. It needs access to MCP servers, so the hands. And it also needs access to other AI agents. And those are the three paths that we have been focusing a lot on in the last quarters and months at Gravitee. So our AI gateway now supports all three of those interaction styles. Here I'm emphasizing the LLM proxy and MCP proxy, which are some of our more recent releases from a product standpoint. I'll dive into these in a little bit more detail to let you know what they actually each mean, but they're all essential for what we consider to be a modern AI agent to function. So the Gravitee LLM proxy is a new type of API or proxy available on the Gravitee gateway. It can be built, you can build it and deploy it on the same gateway that you're used to, up to you to choose if you want to shard or distribute gateways for different use cases. And the LLM proxy, the founding idea of it is that it exposes a uniform interface, pardon me, to agents so that an AI agent doesn't really need to know what provider it's consuming. It just needs to know one single API and can then easily consume models across different providers. So it creates that indirection layer. And it gives you, as an enterprise, a unified point of control to view and understand who's consuming what models, how many tokens are being consumed, at what cost. It also lets you implement unified security models. So you can, for example, share accounts or share API keys for the model providers, but then redistribute those among different end users and control that access at a different layer. It also lets you do things like guardrails. It lets you implement token rate limiting, where we're actually going to be counting the number of tokens consumed by each request so that you can actually control consumption across many different models and make sure that you don't have one application or one developer that's using up all of your quota so that there's nothing left for other teams in the organization. And of course, we have a list of supported model providers, so ranging from OpenAI, Gemini, Bedrock, any OpenAI compatible provider, and we'll be adding more of these as we go along. We're looking at Anthropic very closely, and are happy to work with all of you to figure out where you would like to go next. And I'll also emphasize that although today we are exposing these models through an OpenAI unified API, we do see a world in which we'll start having to add different entry points onto this proxy that are maybe more specific to certain models or certain providers that have very niche or specific APIs. So we're not locked into this model forever. We will be evolving as we go along. The next important component I want to highlight here is the Gravitee MCP proxy. So this is in a similar vein to the LLM proxy. We're creating an abstraction layer between AI agents and MCP servers. So you don't want your agent to be directly tightly coupled to an MCP server. You want to have some level of control on top of that. And the more I talk to customers, the more I realize that customers will have many MCP servers in their organization. They're going to have, some of them are going to be built using Gravitee's tools. Some of them are going to be homemade MCP servers. Some will be off the shelf. But that's a lot of MCP. That's a lot of tools. It's a lot of context that can really bloat what your AI agent sort of can understand of the world and provide it with too many options. So you're going to want to have some level of curation and control before you plug your agents onto those systems. You also want to make that experience a bit more easy in terms of how you actually connect and register MCP servers. But in essence, this is a very special proxy type because it can actually understand the MCP protocol. MCP is a remote procedure call type protocol, so it uses HTTP as a transport layer. Every request is basically a post request with the same URL. You have to look inside the payload to really understand, is it calling a tool? Is it listing tools? Is it loading a resource? And that sort of thing. So this proxy understands that protocol natively, which means that we provide you with analytics about exactly what tools are being called, what MCP errors are being returned. You get real visibility into that protocol, which you wouldn't get from a normal HTTP proxy. And it also lets you apply things like ACLs to control exactly which consumers are allowed to invoke which MCP methods. You can even control which specific tools are allowed to be consumed. You can get very, very fine-grained in terms of the level of control you can apply there. And the last piece I'll highlight is the authorization piece. So the MCP specification includes quite a lot of work, and they've been investing and iterating on that part quite a lot from a standards point of view. Early days, the protocol was not very mature in terms of how they managed authentication and authorization, and we're getting somewhere a bit more industry standard now. Our commitment is that we want to make sure this proxy is compliant with the standards, so you can easily plug and play any agent onto the proxy, and it should just work out of the box. But we are also trying to help offload some of the work of an MCP server developer. So the MCP protocol requires certain RFCs in terms of OAuth 2.1 and things like that so that an agent can correctly authenticate an end user to an MCP server. We're offloading some of that load from the MCP developer, and we can handle that in the gateway directly. So you can connect the gateway to an authorization server and handle all of those MCP discovery and authorization flows directly through Gravitee. Now, just switching gears a little bit, I talked a lot about LLM proxy, MCP proxy, so very sort of data plane centric aspects. But there's a lot of difficulty and challenges today around identity management and access management. And as I'm sure many of you know, we have had an access management solution for many years. It's highly, very feature rich, very feature complete, and it's become a key strategic product for us in this new era of agentic AI, because we see a strong need to better manage the identity of all these new assets, whether it's AI agents, MCP servers, and the authorization rules that govern which of those entities can do what. And the fact is that today it's quite hard, and talking to customers and from our survey, it's kind of hard to really know who really at the end of the day owns AI agent behavior. Is it the data teams? Is it the security team? Are they engineers, central IT? Everyone kind of has a slice, and it's not very clear who is fully accountable. And this creates a real gap in terms of governance. I'm sure some of you have already felt this before. And we've seen places where customers and companies are already getting burned by this lack of governance. So a few key ones I'd highlight are things like tool misuse. So this could be an agent calling the wrong tool or calling the right tool, but in the wrong context. So for example, an agent could discover a powerful internal billing tool or customer deletion tool and invoke it without proper checks. How do you make sure that every agent in your company is only allowed to use sensitive MCP operations in a certain context or in a certain way? You need to be able to express rules like, an AI agent can only read customer data but cannot cancel their subscription unless explicitly authorized. You need to be able to express those kind of rules at company level. There is also a risk of identity abuse. So this is where AI agents are acting without a clear identity, or if they're impersonating other users. So this will typically happen if AI agents, they use shared API keys or they use credentials from somewhere else. And so at the end of the day, if you're looking at an audit trail and you see a bunch of actions that got taken, you can't really trace them back to a specific agent, because that agent's identity was not properly managed and it didn't manage its own credentials and permissions. We also have risks around insecure communication. So, PII or data leaking and going out to models or tools. And there's also a risk of rogue agents, where an agent can enter a loop and start flooding your systems and behave in unexpected ways and generate and incur a lot of cost, or at least use up your quotas and things like that. Now, in terms of what we're doing at Gravitee when it comes to agentic IAM, so we want to make agent tool access enforceable. It's kind of one angle that you could look at in terms of what we've been working on recently. So our access management solution is evolving. It now allows you to do things like explicitly define MCP servers and managing authentication to MCP servers. So if an agent wants to access, let's say, a customer MCP tool, the MCP proxy will redirect the user to Gravitee Access Management. The user will authenticate, consent to the agent using this MCP server on its behalf, and only then does the agent get a token that it can use and invoke the MCP server. And OpenFGA is a permission engine that we've started to integrate and embed into access management. The challenge we're seeing in enterprises is that when you start managing APIs, event streams, AI agents, you don't want to spread your authorization logic into too many different paradigms and too many different tools. And tools like solutions like OpenFGA allow you to create a uniform, centralized definition of authorization across all these different assets. So OpenFGA basically stores relationships and permissions as facts, and you can answer structural questions like, for example, can this user delegate this action to this agent, or can this agent call this MCP tool, or is this resource even visible externally? And so it lets you express rules like user Alice is allowed to read customer data. Her agent can read customer data only when representing Alice. That's sort of a relationship becomes explicit and auditable. And authzen is another key piece of this story. So authzen is what you would call the policy decision point. So it basically answers yes or no at runtime to determine if an action is allowed or not. So basically, you can consider that a request comes into Gravitee, or an agent is trying to take an action. Before that action can happen, you check it against the authzen endpoint, you provide the necessary context, and your authorization engine can then determine if that action is permitted or denied, and can respond back, and then that can be denied at the agent level. So having said all of that, if we just take a step back, and some of you may have seen this diagram before, Gravitee today is uniquely positioned because we can help you govern and control and observe the interactions that are happening across your entire agent ecosystem. So whether it's an agent calling an LLM, an agent calling MCP tools, agents interacting together, whether it's managing the identity and the authorization of agents. And I didn't talk about this too much, but you'll see us go more and more down the path of cataloging and controlling MCP servers, A2A agents, LLMs deployed across different platforms as well. I'll just pause there for some water. Okay, so I'll jump to the demo in a couple minutes. Before doing that, I think it's just useful for those that maybe are not entirely familiar to recap kind of what an AI agent is essentially and what it does, just so we have a common framework to understand this. So an AI agent is an autonomous system that has perception and reasoning. And the core pattern behind basically every AI agent orchestration is as follows. The first one is that the agent will perform discovery. So whether it's at startup or dynamically at runtime, it needs to discover the tools and agents that it can interact with. All right. So the tools could be things like, looking up the weather, booking a hotel, and other agents might be things like, a train booking agent or what have you. It needs to know about the systems it can interact with. The second step is about decision making. So this is where the agent uses an LLM. It's going to take a user input, analyze it against the capabilities it has, the MCP servers, etc., and decide what action to take. So it might decide that based on this user query, the best action I can take is to invoke another agent or to invoke an MCP server. Step 3 is execution. So it's all about actually calling an MCP tool or delegating a task to another agent. This is where we're really hitting the hard runtime aspects of what an agent will do. And then once that happens, you get a result back and you reflect upon what happened and take that as additional context and now iterate until you've basically reached your goal, or that you've reached the maximum number of iterations that you've been allowed as an AI agent. So that's a very useful framework to think about what an AI agent is and what it does, and will help maybe also frame the little demo I'm about to show you. So this demo is called the Acme Hotel Booking Demo. Very thankful to our field CTO, Dorian, who built this. The idea is that you're a company in the hotel booking space, and you've got a website for booking hotels, and you've decided that you want to make your website agentic, right? So you want your end users to be able to interact with a chatbot to book hotels and investigate and look at their reservations and those sort of things. And this is a perfect example to illustrate all those different layers I talked about, whether it's the agent identity, the end user identity, the authorization rules that govern those, the REST APIs that have turned into MCP servers, the A2A protocol interactions, the MCP server interactions. We've kind of packaged all of that into this demo to show you how it all works in real life. And before actually switching to the demo, I'll just take you through the high-level architecture of this example. So the first thing I'll say is that on the right here, you have your core REST API. So I've got the accommodation API and the, let me see if I can get the mouse somewhat useful here. Okay, so we've got our core REST APIs at the top right here. So the accommodation API and the booking API. So accommodation is basically to list available hotel. And the booking API lets you actually book and manage your own individual bookings. And because these are REST APIs, we're not just going to give them directly to an AI agent. We're going to convert them into MCP servers to make them more AI agent friendly. And that's something that we can do with Gravitee with our MCP tool server. At the click of a button, basically, you can take your REST API, provide the right open API definition, and we'll generate an MCP entry point for that API. And so that's managed today on the Gravitee gateway. And you can see here that we have two different plans, so two different levels of access. There's an open plan, which lets you explore available hotels. But then the second that you want to start managing your individual user bookings, you're going through a restricted plan, which is secured using OAuth 2. Next step is we have the LLM. So I'm running, in this demo, I'm running a local model with Olama, but you could be hitting any potential backend LLM that's managed by Gravitee. And again, instead of the AI agent directly having being coupled to OpenAI's API or to Gemini, it's going through the Gravitee gateway first. So I can very easily switch models. I can switch from a local model to Gemini. I can do all those kind of changes without actually touching my AI agent's code. And I'm also able to implement some checks here and doing things like tracking token usage, implementing rate limiting, putting in place some guardrails, and I'll demonstrate some of those. Now, if we come to the left here, we can see that we've got this AI agent here, which is, think of it as like a headless kind of backend agent. Its job is really to manage bookings and look at available hotels. But we've actually got a multi-agent architecture here where I've got a front-end application, a web application, which itself is agentic because it's a chatbot. And so it actually interacts with me as a user and decides to potentially invoke this AI agent when needed. So it starts up with knowledge of this AI agent in existence, and it can use the A2A protocol that calls to the agent to look at available hotels or to manage a user's bookings. And finally, we have Gravitee Access Management. So because we're talking about an end user's individual bookings, at some point, I'm going to have to log in as a user, and we're going to have to verify that I'm accessing resources that I'm allowed to consume. So we've set up Gravitee Access Management that is running as an authorization server, and it's acting as a OpenFGA policy decision point. And now when the chatbot essentially realizes that it's trying to access a secured resource, it's going to tell me as a user to log in so that it can get a token that has the right permissions to then consume the resources that it's trying to access. So without further ado, let's open up the demo and pray to the demo gods that they will be friendly today, because this is 100% live. Okay, I'll just do a refresh. So this is the Acme Hotels website. So of course, I'm a modern user, and I'm going to go straight to my chatbot. I'm not going to do the old school way. I want to know about the hotels that are available in Paris right now. So I'm going to type a message like, show me hotels in Paris. So this, again, is triggering an agent-to-agent interaction. And then the backend agent is going to discover the available MCP servers, and it's going to pick the hotel availability MCP server and list available hotels. So I'm getting some responses there. That works very good. The next step is I might have actually already made some bookings as an individual. So I'm going to ask the app to show me my bookings. And now the agent is telling me that I need to be signed in to complete this action. So it's telling me to sign in and try again. So if I come into Gravitee for a second here, and I'll come back to the demo in a second, you'll see I've got a number of APIs implemented here in the API management solution. So I've got my AI agent exposed using the A2A protocol. I've got my hotel backend API, I've got the LLM proxy, I've got the MCP server. And if I just have a look, for example, at the hotel API for a second, and I take a look at its logs, you'll see here that I got a 403 when the agent tried to look and fetch the hotel bookings. So that's why I'm not permitted right now to look at my bookings. I'm not authenticated. So if I go ahead and log in, so you can see here I've clicked sign in. I'm actually using Gravitee Access Management to manage the identity of end users as well. Okay, I'm going to give consent here to the Gravitee Hotels application and hit OK. So now I'm logged in. I can head back to my chatbot and ask it to show me my bookings. This time, I'm not getting a 403. I'm logged in. I'm able to now access my own bookings as an individual. So that works. And I'm very happy I'm able to consult my bookings through the application. Now, there are obviously a bunch of other things that we can do here. So let's take, for example, if I was to say, show me my bookings, you idiot. So let's be a little bit rude. This sort of request is going to be rejected. And the reason for that is that I've implemented guardrails on the LLM proxy, which are detecting here that there's some toxicity in my message. I'm a bit angry, and it's going to reject that request. It's never even going to hit the LLM in the first place. To show you how that works, what I've done, if I head over to my LLM proxy, and I look at the policies that I've implemented, you'll see I've got an AI prompt guardrails policy here, which is put in place to block toxic requests. So if I have a look at how this is configured, you'll see I'm referencing an AI model. So what we're actually able to do is run very lightweight models from a set that we've curated ourselves on the gateway directly. They can be used to classify requests coming in and out to determine if they are toxic, or I can actually choose what kind of checks I want to do. Is someone trying to jailbreak my model, and those sort of things. And I can configure the sensitivity, and I can also determine if this request should be blocked or if it should just be flagged. Because sometimes you might not want to block. Blocking can sometimes be a bit strict. You might at least want to flag things so that you can check your analytics and logs later and see which requests are being flagged and kind of diagnose that and sort of learn about what's going on. Now, the other thing I can also try and do is spam my chatbot. So let's put in one first request and then another. Okay, so you see here I've hit a rate limit. I sent 2 requests at a very short time interval, and it's telling me that I've reached my limit and that I need to wait 4 seconds before I can send a new request. My limit is 400 tokens, and I've consumed all of them. So for the demo, I've set a very, very short rate limit here. And the point being that it's to show you how easily I can control the amount of tokens that an end user can consume through this application. And to show you how that's implemented, you see here I have the token rate limit policy. So if I take a look at how it's configured, you can see that I have a maximum number of tokens, and I have a time duration in seconds. So currently the limit is set to 400 tokens every 10 seconds, which is very short. You probably wouldn't want to set something like that in real life, but you can of course configure that to different time periods and manage that how you would like. And as with many Gravitee policies, there are all kinds of conditions and things that you can put in place to determine when you should trigger these limits or not. And you can also use keys to identify a specific consumer or a group of consumers. So this is a way that you can distribute the quota of LLMs fairly across different consumer groups, so you can make sure that a single person isn't using up all of your quota. While I'm on this screen, I'll just show you a little bit about how it's configured. So on the endpoint level here, so the backend services, you can see I've configured 2 different model providers. I've got Olama and I've got Gemini set up. So you can set up multiple providers for a single LLM proxy, and you can configure multiple models within each provider. So I can actually control exactly which models I want to expose or not. And we will only allow the use of those that you've explicitly referenced here in Gravitee. The LLM proxy also implements the models endpoint, so an agent is able to dynamically discover what models are actually available. Awesome. So the other thing I wanted to show you is that, as you can imagine, a developer has had to build this application. So someone has had to code this AI agent and the website and everything. You're obviously going to want to know and learn about what what these APIs are, how you can use them. So all of my APIs are currently deployed here on the published on the developer portal. So you can see I've got my AI agent that I can use. I've got my hotels APIs. I've got my LLM proxy. I've got my MCP proxy. Everything is documented here so that as a developer, I can easily figure out how to use these things. If I look at my MCP server, you can see that the MCP tools are clearly documented on the portal as well. So I can see that I have one method for getting accommodations, and I have one for getting my personal bookings. We often use tools like the MCP inspector to check that our MCP servers running through Gravitee are behaving as they should. So if I connect here to my gateway and I connect to the hotel's MCP server, I can also list the tools and start playing around with them here as well as a test environment. So you can see I have the same tools visible here from this environment. Okay, so with that, I think I'll just jump back to the slides for a second. So I think, throughout this webinar so far, I've kind of highlighted some of the reasons why an AI gateway is important. I think if you look at some of the stats like those raised by Gartner, that some of the top performing organizations today are using some form of AI gateway to improve their performance and productivity with AI use cases and AI agents. The Gravitee platform today lets you manage the full life cycle, not only of AI agents, but also your APIs, your events, MCP servers, LLM proxies, agentic identity, all from a single unified platform. Why acquire multiple different tools if all of these sort of interaction mechanisms, these paradigms are all quite similar to REST APIs and can easily be extended to managing your events and your agentic interactions as well. So I hope you enjoyed this webinar. If you're interested in learning more, please do book a demo with us. The demo I showed you about the hotel booking is actually something that we can take you through together during a demo, and you can actually run through it yourself. So if that's something you're interested in and you'd like to go one level deeper on how all that stuff is configured, please do reach out and book a demo with us. We'd love to take you through that in a lot more detail.